So we're looking at section 3E now, which is entitled How Numbers Can Deceive, and most specifically we're going to look at Simpson's paradox. At the top there you see a link to a YouTube video. It's definitely worth watching. It's just a guy explaining the idea of Simpson's paradox. I'll give you one example here, and hopefully you'll find it very straightforward and probably one of the easiest topics that we've looked at so far. Essentially, Simpson's paradox occurs whenever you look at the data in one particular fashion and you get one conclusion, and then if you look at the data in another fashion, you get a totally different conclusion. And so there's that idea of a paradox, but yet it's the same data, but ordered differently. So that's what we're looking at here. We're looking at hospital death rates, for example, comparing two hospitals, Hospital A versus Hospital B. In Hospital A, 63 have died, 2,037 have survived, for a total then of patients that have gone to this hospital. Adding those two numbers together, you would find that to be 2,100. And then for Hospital B, for 16 to have died and 784 survived, that would be a total of 800 patients that have visited that hospital. Then ultimately we want to look at, well, what percent then survived at each of those hospitals? So if we look at Hospital A, the percent that would have survived would be the total amount that had survived, 2,037, divided by the total number that went to that hospital, 2,100. You're finding a percentage, so you'll take that division and multiply by 100. And that should put you at a perfect 97%. So 97% of the patients that arrive at that hospital do survive. Hospital B, on the other hand, if we want to figure out the percentage that survived there, we look at the number that have survived, 784, out of the total 800 patients, multiply by 100, and if we do that division and multiplication, you would find that to be 98% of the patients that enter that hospital will survive. Okay. So on the surface, looking at the data combined like this, it would appear that those that go to Hospital B seem to have a better survival rate. Okay. However, if we take this data and examine it a little bit closer in terms of, okay, well, this is still the same number of people that are going to these hospitals, but let's look at it in terms of good condition versus poor condition whenever they enter the hospital. So for example, here then I say, okay, in Hospital A, 6 died, 594 survived that went to Hospital A in good condition, for a total then of 600 people in good condition going to Hospital A. Likewise, 600 people going to Hospital B after adding those 8 and 592 together. So now we have a total of 600 going to both hospitals. When we do now the percent that survived here, 594 divided by 600 multiplied by 100, that should give you a 99% survival rate. And then Hospital B then would have a 98.7% survival rate, where I was doing 592 over 600. Okay. Now if we compare over on the right hand side to those that entered the hospital in poor condition, Hospital A, 57 died and 1,443 survived, for a total of 1,500 patients come into the hospital. And Hospital B, those that entered there in poor condition, only 200 went to that hospital. To find the percent that survived, take the total number that have survived, so 1,443 divided by the total 1,500, multiply that by 100, you would have 96.2% surviving going to Hospital A. Hospital B, the percent that have survived, 192 out of 200, and that's going to be 96%. So as you can see here, once the patient's condition has been taken into account, we can see that Hospital A has a better survival rate in both cases. Patient condition, for example, here is what's called the lurking variable. Lurking variable isn't something that you'll have to be, concerning yourself with, but just so you know, that would be something that you'd actually look more at in a statistics class. Example 2 is very much the same. I'll let you definitely give yourself a try at seeing this idea of Simpson's paradox. But this previous example does exhibit Simpson's paradox because when grouped together, hospital B appears to be the better hospital to go to. However, when separating by condition, it then appears that hospital A is the better hospital to go to. On the second page, you'll just find problems where that you are looking at finding the percentages among various groups, and I think that the solutions key provides a nice explanation with the numbers that are used to solve those problems, so I'll let you reference that for the back page here. Thanks.